guys, today I'm doing Khan Academy weather. Let's start.
In a good mood, put on your absolute favorite outfit, went outside to have a fun day in the sun, and then ended up soaking wet, caught in a sudden rainstorm? Yeah, same. Unfortunately, we can't control the weather. Weather changes from day to day and from place to place, so scientists have to consider a lot of different factors to understand it. Weather can refer to humidity, or amount of water vapor in the air, temperature, air pressure, wind, and of course, precipitation, like rain or snow. When heat from the sun enters Earth's lower atmosphere, it affects the temperature and humidity of the air. As this National Aeronautics and Space Administration map shows, air masses with certain characteristics tend to form in similar places. There's many ways to classify these air masses, but to keep it simple, these blue blobs represent colder air masses, which tend to be closer to the poles, and the red blobs represent warm air masses, which are often found near the equator, where the sun's energy is strongest. The qualities of an air mass may also depend on where it forms. Air masses that form over land tend to have less humidity than those that form over an ocean. Air masses can even change characteristics as they move. For example, when a very cold and dry air mass moves over the ocean, it will likely pick up warmth and moisture, transforming it into a slightly warmer and more humid air mass. Weather results from these air masses moving from areas with high air pressure to areas with low air pressure. When this happens, a high or low pressure system can form. A high pressure system has higher pressure at its center than the areas around it, so air moves out from the center. High pressure systems typically bring clear skies. A low pressure system has lower pressure at its center than the areas around it, so air is sucked into the center of the system. Low pressure systems typically bring more intense weather. Why is this? Well, low pressure systems are often associated with what we call fronts. A front is a boundary that forms when air masses of different temperatures collide near Earth's surface. Different types of fronts can form depending on how those air masses meet. A warm front occurs when a warm air mass moves in to replace a cold air mass. Since warm air is less dense than cold air, it rises above the colder air, causing a lot of overcast skies, moderate rain or snow, and warm temperatures. A cold front occurs when a cold air mass moves in to replace a warm air mass. The dense cold air pushes the warmer air mass upward, causing larger clouds to billow overhead and bring heavy rain or thunderstorms, strong winds, and cool temperatures with them. Weather is so complex that it can be difficult to predict what will happen next. Luckily, scientists have developed technologies that help model weather patterns, so we can all make more informed choices about what to expect when we go outside. To do that, they set up tools like satellites and Doppler radar to observe atmospheric conditions, such as wind speed, temperature, air pressure, and nearby geographic features. They can input the data they record into computer models, which can use that information to predict future weather. Have you ever seen a map like this used in a weather forecast?
Yeah.
This National Oceanic and Atmospheric Administration map uses data from a Doppler radar station that measured the
I've seen it before.
progression of a severe storm over the northeastern United States. The most intense central parts of the storm are shown in red, with colors down the rainbow representing progressively less intense parts of the storm. As technology has advanced, these weather reports have gotten more accurate, but with so many factors to consider, weather is still only somewhat predictable. That's why you'll always hear probabilistic weather predictions, providing a percentage that refers to how confident the model is that the prediction will happen. If your local weather forecast says there's a 30% chance of rain, it's less likely but still possible that you're going to get rain. If it says there's a 90% chance of snow on another day, you're most likely going to get snow. Even if weather predictions aren't perfect, it's amazing that scientists figured out how to understand such a complicated phenomenon. Without modern tools and models, it would be much more difficult for us to plan ahead and be prepared for possible weather hazards. Next time you have a fancy day out planned, be sure to check the weather forecast before you go. If it says there's a decent chance of rain, don't forget your umbrella.
Okay. Next one. Ready. Weather is the state of the atmosphere at a given place and time. Weather is defined by factors such as temperature and wind. Changes in the weather are caused by the movement of air masses. An air mass is a large body of air with uniform temperature and humidity. In general, air masses give more areas of high pressure to areas of low pressure. As air masses move, they collide and form weather fronts. A cold front is when a cold air mass moves into warm air mass. Cold front usually brings cool temperatures and heavy rain or thunderstorms. A warm front is formed when a warm air mass moves into a cold air mass. Warm fronts usually bring warm temperature and moderate rain. Scientists make weather predictions by collecting current weather data and inputting it into computer models. Because weather is so complex, those predictions are only probabilities and not certain outcomes. Okay. Next is an exercise. Let's go. What are two properties that define air mass? Moisture and temperature. A warm front occurs when warm air moves into cold air mass. How do air masses move in the atmosphere? From areas of low pressure to high pressure, from areas of high pressure to low pressure. Let's go back here. Okay, how do they move? In general, air masses move from areas of high pressure to low pressure. From areas of high pressure to low pressure. You can always look back to get an answer. What type of weather is associated with cold fronts? Thunderstorms. Wow, a one streak. Yeah. Next. Quiz 1. Okie dokie. Let's go. 5 problems. During the condensation step of the water cycle, water changes state form. Water changes state from condensation is water vapor to liquid vapor. Liquid vapor. No, that's wrong. Liquid water, not vapor. Which two properties define an air mass? Humidity and temperature. What are the two main drivers of the water cycle? The sun's energy. Oh wait, 2. Earth rotation. No, Earth gravity. Yeah. Earth gravity drives the movement of water from the atmosphere to Earth through precipitation. It also causes water on Earth's surface to move downhill. Oh, that's how. Okay. How does a cold front form? Can I retry this? Oh man, I can't. Front forms when cold air moves into warm air mass. Which water cycle returns to Earth water to Earth's surface? Transpiration or precipitation? Precipitation. Next one.
One of my favorite things to do is go camping. For me, there's nothing better than getting outside, breathing in some fresh air, and taking a swim in my favorite river. Have you ever jumped into a river and felt that the deeper, cooler water closer to your feet was moving faster than the shallow, warmer water at your knees? That's a current, which is the word we use to describe how water, or even air, flows within a larger body of water, or air. But what causes a current? Well, let's start with the sun. The sun actually heats Earth unevenly. We know that it's hotter near the equator and it gets colder as you go towards the poles. Near the equator, the sun's rays hit Earth's surface more directly, while near the poles, the sun's rays hit Earth's surface less directly. In both regions, the same amount of solar energy is hitting Earth, but near the equator, this energy is concentrated into a smaller area, and near the poles, it's spread out over a larger area. So, the regions near the equator get more solar energy, which makes them warmer, and the regions near the poles get less solar energy, which makes them cooler. This uneven heating of Earth also affects air pressure. Where it's cooler, near the poles, cool air will sink, making the air pressure high. But where it's warmer, near the equator, warm air will rise, resulting in low pressure. This is where the terms low pressure cells and high pressure cells come from. The low pressure, warmer air at the equator rises into the upper atmosphere where it cools and flows away towards higher latitudes, away from the equator. Because the air is now cooler, it starts to sink again and creates a high pressure band near these latitudes. This process repeats and creates a pattern of high and low pressure bands from the equator to the poles. We know that air flows from areas of high pressure to areas of low pressure. This creates air currents, or winds. Now, you might think that these winds would blow in straight lines from high to low pressure areas, but the global wind patterns, which we call prevailing winds, look like they curve to the right in the northern hemisphere and to the left in the southern hemisphere. This curving has to do with the rotation of Earth and is called the Coriolis effect. As these prevailing winds blow across the surface of the land and water, they also push against the surface of the ocean and produce wind-driven surface currents, which help to move ocean water. Here's what the global pattern of ocean surface currents looks like. Like wind currents, ocean surface currents are also curved due to the Coriolis effect. We can see that in these currents that are traveling north and south, which curve to the right in the northern hemisphere and to the left in the southern hemisphere. Together, as these surface currents of the ocean connect, they form giant rotating systems of ocean currents called gyres. The currents that drive these gyres extend from the surface to about 1 kilometer down into the ocean and help to move water all around the globe. But these gyres aren't just moving water, they're moving heat energy as well. Water is pretty good at holding onto heat it absorbs from the sun.
Bye guys, that's all for today. Please like, subscribe, and hit the notification bell. Thank you for watching. Bye.